What do you mean by CPM, critical path method? This is the procedure that you do. Okay, so first, what do? You break down the project. So, any particular project. Let's again come back to something very basic that all of you can relate to. Okay, so you have a house that you have to build. Okay, your particular house will have different activities to be done, right? So you have the foundation or anything that's below the soil. You have the superstructure. Okay, and you have roofing. You have interiors, all of that. So you break it down into all of these activities. So that's your project breakdown. Then you create a network diagram. Sorry, one second. Okay. Ha. You create a network diagram where you talk about the relationship between all of that. So, say for example, you cannot build the superstructure until unless your substructure is complete, right? So automatically that becomes your activity that you complete first. Your subsoil and substructure becomes your first activity. Once you're done with that, you come to the superstructures. Okay, so this is how you lay down the network. So you have a network diagram. So you break it down into smaller processes, smaller activities, smaller tasks, and then you connect them. Okay, you try to understand what are events, what are activities. So anything where you're performing an action, where you think it needs time, it becomes an activity. Simple as that. Okay, and all of this, okay, need time and cost. Right, your activities need time and cost, and all of these activities are indirectly influencing your completion time. Okay, they're ultimately going to be influencing that. Your activity time, so each of your activities will have time, that's what they're talking about. Then they're talking about floats. Okay, so float is another concept or another term that you should all know. So far, we have learned two different methods. We've learned critical path method and PERT. Okay, right? We're looking at the overviews of both of this. We're starting to go a little deeper into how do you, work the critical path method, or how do you actually um, create a network using the critical path? How do you identify that critical path, right? So in this, we learned three different terms. We learned activity, we learned node, and we learned dummy activity, right? So in activity, I'm just going to go back to that slide just for refreshing your mind. So activity is basically your occurrence of a job or an activity or an action where you need time. So verbs, okay, anything that you're walking, anything that you're building, you're painting, you're excavating, you're mixing, all of these become activities. Okay, the start and finish of that particular, whatever that particular performance was. If you're mixing, the starting of that mixing and the finishing of that mixing become your events or nodes. This is how you represent. And then dummy activity are all of these dotted arrows, which talks about the interdependencies. Okay. Now, over here, we're going to come to a fourth term, which is called a float. Now, what is a float? It talks about the flexibility of an activity. Okay. So at the start, I will actually give you an example of your gate preparation, right? If you remember. So in your gate preparation, okay, we were talking about, let's say you have your exam in Feb and you have 6 months ahead of you. Okay, and you're preparing different topics across all of these 6 months. Okay, so there might be, let's say, I'm just going to take one of your names. So Taruvar from here is going to be taking, um, okay, so Taruvar is, let's assume that he is planning in such a way that in a week, okay, he has 7 days. So what he does is he plans for completing one unit in 3 days, and he plans for completing the next unit in 3 days, and he plans to solve questions on that one common day. Or say let's say he takes a break on that one day because he wants to. Okay. Whereas another person, instead of doing this, decides to do a unit in 3 days. So I'm taking the example of Pallavi now. So let's say Pallavi does a particular unit or particular chapter for 3 days, takes a break for one day, and then continues to finish another unit in 3 days. So both of these people are technically taking the same time to finish this work, right? But what Pallavi or what the second person actually has over here that is not visible to all of us is that flexibility, right? So if I'm not able to finish this particular unit in 3 days, I have this extra bit of time that's available with me. Okay. Whereas in this particular case, if I'm not allowing, say, a buffer day in between, then automatically I am constrained to finish my work within these 3 days, right? So this float is that particular concept of buffer. Okay. How much time can you actually, give in between, before you need to complete that task or before you need to start the next task? All of that talks about flow. Now, again, we have different types. So, similarly, like how an activity, matlab, you don't have just one activity, right? You have the activity, you have parallel activities, you have predecessor and successor activities. Similarly, floats are also of different types. So the total float is something that is for the entire project. Okay, so your particular activity can be delayed without causing an impact. Okay, how much of that flexibility in the entire project is called total float. Okay, so I have a task for 3 days. I have a buffer of 1 day, and then I have another task for 3 days, right? Similarly, I have 2 more days ka buffer, and then I have another task for 3 days. So in this case, my total float is 1 plus 3. The entire project ka flexibility that I have is your total float. Your free float is basically the start of the succeeding activity. So your particular task, matlab, your succeeding activity. So you have an activity A, you have activity B, you have activity C. Now the free float for A is 1. Okay, because before the start of the succeeding activity, how much time do you have? That is your free float. Okay, and your interfering float is basically total float minus your free float. In this case, 1 plus 2, which is, sorry, 1 plus 2 in this case, equal to 3 likha tha. So 3 is your total float in this particular case, and your free float in this case is 1. So 3 minus 1 is 2, which is your interfering float. Okay, this is how simply, very, very basics how you can calculate it. Okay, and it is critical if it is 0. So in critical path method, we are finding what are the critical activities that are required for completing that particular task. And how do you know a task is critical? Your float has to be 0. Basically, if you extend a little time of that particular activity or particular task that you're doing, then your entire project gets shifted. So you cannot touch those activities. Such activities are called critical activities, and those activities, when you connect all of them together, it becomes a network or it becomes a path, which becomes a critical path. Okay, so in our numerical, when we go, you'll understand how this comes into play. But basic understanding is this, that your critical path is where your float is 0. So now we know what total float is. Now we know what free float is. Now we know what interfering float is. Okay. Like I said, your determination of critical path is based on the path with 0 floats. It's usually the longest path in the network. Okay. So scheduling, you need time and float calculations, which is used to prepare a schedule. So this is how your entire procedure for a critical path method is. You will be able to understand this entire process when you actually solve a numerical or when you solve a sum. Okay, so we'll actually be doing that today. We'll actually take a look at one particular sum and we'll try to see how all of this comes into play. Okay, so practically, when you look at it, you'll understand it much better. And a few more terms that you need to know before I go into the sum are all of this. Okay, few more terms and few equations that you should remember. This is, I'm not expecting that you understand or grasp all of this in just an 1 hour or a 2 hour session. I want you all to just go back and take a look at all of this um, equations. I want you all to go back and take a look at all of these terms. I want you to take a look at how we have particularly done that particular sum and solve more sums or solve more similar questions and then understand all of that. Okay. So some more key terms that I need you guys to know is earliest start time, earliest finish time, latest start time, latest finish time. Okay. So let's say you have an activity. Your activity needs 3 days, is what we know, right? Your particular unit, studying a unit is your activity in this case. It needs 3 days. This is our understanding so far. We have been looking at projects, or we've been looking at networks with this understanding. So your earliest start time is always 0. Why? Because you're starting, you don't have anything. It is not dependent on anything. That is your EST for the first activity. Okay, so we're looking at one activity individually. So I want you to understand EST, which is your earliest start time, is this.